Hey, everybody. Thanks for coming today. I want to introduce our speakers today for this awesome presentation of Avesha and Akamai. So, Colin Devine, Partner Ecosystem Manager. I work to make our partners successful on our Linode cloud. You're going to hear more about Akamai Connected Cloud, Linode Cloud, same thing. I've got my good friend Nathan Lasure here. He's an enterprise architect. Real simple. The white button up says, do not ask me technical questions. Refer to them to my friend Nathan for anything technical. And then we got Dave Comrie from Avesha, Field CTO. Dave, you want to introduce yourself? Is that mic working?
Audio. Yeah, there we go. Hey. Yeah, Dave Comrie with Avesha, Field CTO here. Thank you all for coming. And we're going to go through a whole bunch of stuff that brings edge and AI workloads to this awesome Akamai edge that we love deploying stuff to.
Thank you. It's all about connecting an open source partners with the customer. So let's go to the next slide. So a couple of years ago, as you're probably aware, Akamai purchased Linode, integrated it into our network. We've done a lot of great work over the last few years to really expand the capabilities on the locations. We have another slide on that. The storage, compute. At the same time, building out our partner ecosystem. Right, you have to have fantastic partners like Avesha. And this is one subset. We're continuing to grow this every day. If you want to be part of that cool ecosystem, come meet me right after the slideshow today. We'll help set you up. Next slide. I'm going to turn it over to my friend Nathan for this one.
So you might be familiar with Akamai from a CDN edge security standpoint. One of the big things that we are trying to do here is move compute workloads as close to the user and the edge as possible. For those cloud native applications, we have our cloud compute platform, but we also, for edge native, have edge workers and WASM functions that can execute at the edge where our CDN and security platform live. And then in addition to that, we've also connected our cloud computing regions with our existing networks to accelerate the traffic between our CDN networks and our cloud compute networks.
Awesome. Thank you, Nathan. So how many regions are there? We are expanding all the time. It's real simple. If you got a workload out there, we got a point of presence right in your neighborhood. Where the workloads are, where the people are, that's where we are. And if people move, workloads move, we'll open a new one. We do that all the time. We're upgrading them all the time. You can see what we've done here. Just 2024. I did maybe an old slide. We got to get a new slide there for 2025. We're upgrading all the time. As Nathan said, we've got all the major components set up, including, next slide, all the major services you need. So from this GPUs, the VPUs, premium CPUs, storage, edge workers, all the things you need to do to get your workloads done, we've got ready for you. It's a very simple interface. You log in, everything's right there. It's not overly complicated. We pride ourselves on being easy to deploy, easy to set up, and get started super simply. So we've been working with our good partner, friends. Is friends too?
Yeah,
personal?
No, it's good. It's
good. Let's say friends. All right.
Yes.
Avesha. And we said, hey, we're going to be at KubeCon together. Let's get together. Let's show these guys what we've been working on. So I'm going to pass it over to Dave. Get started on the cool stuff that's going on.
Thank you, Colin. Thank you. Awesome. Well, thank you all for showing up. We're going to talk about Elastic Grid Service today, but as a little bit of background on our company is called Avesha. Actually, our founder is right here, Raj. Please stop by and say hey to Raj if you want to hear the more of the backstory on Avesha. But we've been in business for a number of years. You may have heard of KubeSlice with this super almost like a little bit weird kind of logo dude with a knife on his head. But he's been an open source project with CNCF for 3 years, I believe. And that's fully open source software. We're a big believer in open source, and we definitely support open source deployment, open source kind of movement. But today, we're going to take this KubeSlice concept and we're going to expand it to AI workloads at the edge. And in general, just deploying AI workloads across a distributed infrastructure. So we'll jump right into that. I mentioned KubeSlice is our original project. We also have other patents on scaling technology and especially multi-cluster type technology that can knit clusters together across diverse infrastructures, whether it's on-prem, public cloud, private cloud. We bring all that. Obvious Gartner kind of recognition in the industry. And again, to reiterate, we're a CNCF project with KubeSlice. So we all have problems with AI and getting them deployed. Lots of folks are enjoying kind of messing around with this in the lab. Maybe we're doing some test workloads. We're starting to do thinking about transitioning from development into real production and scaling and putting these out in a more distributed fashion. So, GPU utilization, I kind of think of it as CPU utilization problem, but amplified by the difference in the cost between GPUs and CPUs. So it magnifies if you got, 10% underutilization in CPU, that's equivalent to having like a whole bunch of underutilization in GPU. It just magnifies that aspect of it. So once you get your GPUs very well utilized, now we're going to talk about fragmentation. And that could be in the software tool chains, that can be in the distribution, that can be in just the environment, that fragmented, we call pipelines, but just basic fragmentation in the industry that's happening around AI and GPUs. The complexity when it comes to scaling. So scaling sounds easy. Used to be just HPA. You used to just scale up your pods when you needed additional compute. But with GPUs, it's a little more complex because you have to bring additional nodes into the play. You may need different regions where you need to operate those GPUs. So the scaling complexity, again, goes up pretty critically. And then last thing is around visibility. So traditional visibility tools don't necessarily work the same way when you want to go to AI and monitor GPUs. There's different things. You got to worry more about temperatures. We love those stories about the old NVIDIAs that would like melt down into the server. So you want to have a good beat on how your temperatures are gauging across your fleet, how your utilization, your memory utilization, the GPU utilization. So that visibility, again, is pretty core. What is one to do with all these problems? What we say is you should use Elastic Grid Service. So what EGS is an AI infrastructure virtualization platform, which is a mouthful. But what that means is that we're going to take workloads that you're deploying and we're going to connect it with a GPU somewhere in the world, right? We think that a lot of people are having challenges and don't really like to spend a lot of time worrying about infrastructure and typing up new nodes and kube cuddling things and all this stuff that, as engineers we love, but the end users, the data scientists really don't care. They just have a workload, they want it to run, and they don't even care what kind of hardware it is. So that's our business. That's our job, is connecting workloads to GPUs wherever they happen to be in the world. EGS is very on demand. It's very dynamic and it's very adaptive. And what that means is as you're deploying workloads, I'm just going to find capacity. I'm going to allocate that capacity for some period of time. When that workload is done with that capacity, I'm going to reclaim that capacity and give it to somebody else. Why sit there with idle GPUs? Doesn't make sense. We say that the infrastructure, it's governed by policies. Those could be SLA policies, governance, compliance policy, just capacity, like how many GPUs are you allowed as a user or as a project to utilize within the infrastructure that your company may be running. So where does that all take us? It takes us to the things we do well. We say we're great at scaling. So scalable regional endpoints. There's no one better in the business and scale than Akamai. 254 countries and counting. I think it's all of them. Like pretty much. Yeah, all of it. So scalable, we definitely ascribe to that. Automation, fleet balancing. So think about, I have follow the sun models where there's workloads that are rotating with the globe. Optimization, how do you get the most out of your GPUs? So as soon as something's idle, let's grab another workload and throw it on the fire, right? There's no reason that any cycle in a GPU should be idle. Not at the kind of cost that these things come at. And then seamless hybrid, what we say, we also refer to this as the burst. So if you are an on-premise, maybe you have some SUSE Rancher clusters in your on-premise, you may want to burst that workload up to Akamai Cloud and utilize that on-demand capacity. That's the seamless piece of it. And we facilitate that with basically a no-code bursting application that will just automatically move your workloads to the cloud. So it's a great onboarding, on-ramp kind of value proposition. What's a slide deck without an outcome slide? So, you got to take this to your CIO and convince them that this is worthwhile. So you got to talk about the virtualization at the GPU layer, which is leading to a lower operational overhead. You got to talk about policy-driven distribution. It's no good to distribute workloads unless they're being governed by policy. That goes straight to improved performance. And you got to talk about real-time insights. Again, that observability that's leading straight to your improved TCO. So that's how you get your CIOs on board with this technology. Product demo. Let's do a demo. So we're going to start by logging in to our EGS console. All Kubernetes kind of RBAC, backed by RBAC policy. And the first thing you're going to see is our dashboard. The dashboard is built to be very intuitive, to give you a quick glance visibility by the total number of GPUs in our system. That says 4 out of 5, but in my head, I think 400 out of 500 kind of scale. It gives you an immediate view of what am I currently using in my GPU farm. At this point, I'm using about 21%. And you'll start to see these red numbers jumping out. Red is usually bad, right? Red is bad. So we say if something is available, that's bad for something to be available. We actually don't want GPUs to be available. We want them to be utilized. So as much as they're being utilized, we track that. And then the inverse of that is the amount of waste that you're having in the system. So I'm wasting 1 GPU right now. And of the 4 that I have allocated, I'm wasting 80% of those GPUs. Like, not a great story if I'm like a DevOps guy and I'm going back to my boss and saying, yeah, I'm only using 20% of the GPUs, but can we buy more? The answer is going to be no, you may not buy more. So we break it down by what we call a workspace. This can be a project. This can be a team. This can be, staging, development, production, like however you want to use this workspace concept. It's a very flexible concept. It's just literally a name or a tag, if you will, that represents, I think of it as a workbench kind of thing, where on this workbench, I'm going to put different GPUs onto this workbench. And now as a data scientist, I have these different GPUs I can work with, right? That's what a workspace is a place to go onboard GPUs that I can now, within my little domain, I can work on. So we have one workspace called Inference Slice. It's probably doing inferencing if the name reflects. We have VLLM running on another workspace. and we have a burst inference running on a third workspace. And gosh, those aren't doing anything. Why aren't they doing anything? Maybe I should go fix that if I'm a DevOps guy. Oh, my script stopped. So let's start that up again. And what you see is now we're running inferencing, and we're getting chat completions requests for those in the audience that are into that sort of thing. And you'll start to see that GPU utilization start to creep up. Beyond the summarization, we can also drill down to the specific GPU. I can look at my farm here and see that I've got these awesome Akamai RTX 4000 chips. I'm super excited about the RTX 6000 chips that are coming out because they're going to blow these things up with even greater speed.
Are available.
They are available.
Yes.
Why don't I have them in my demo? I should put them in my demo. That's a failing on my part. So this lets you drill down to the specific GPUs. We also happen to have some L40S and H100. So this is not, again, confined to a single cloud or a single cluster. It's going to identify and pull in GPUs from whichever cluster you happen to have deployed. You can see we do have 2 clusters in the system currently, and my inventory. This gives me a view of all of my GPUs. It tells me if they're healthy or not. It tells me how much they're costing me per hour, and it tells me if they're allocated or available. Again, the red coloring on available bad. We need to put a workload on available, right? That should be our mantra in our heads. So from there, we can see what these workspaces are doing. These were the workspaces reviewed before. This is my favorite column on this screen. This is our overlay network that's built on KubeSlice. So again, that open source project being put to use in commercial offering with overlay. We're supporting OpenVPN and WireGuard, which was actually a community contribution. A company picked up KubeSlice, they added WireGuard to it, and it's super performant. So we really like that VPN connection between clouds. It facilitates east-west traffic without having to waste your time with, what's the one, Swan, anybody? Strong Swan. Yeah, you could literally lose days of your life in Strong Swan, I'm convinced. But this is literally happens automatically when you set up a network and a workspace. From the workspaces, we look at the workloads. So now I can go in and I can see on this burst inference workspace, I have a Llama 3 model. It's currently running on an H100, and it's running 15% utilization. It's 305 watts and 35 degrees C, which that's getting pretty toasty, right? It's about 100 and change. I can also look at our other workspaces. I have an inference slice here that's running a Gemma model. Again, open models, very easy to deploy. This one's running much better on the utilization factor, RTX 4000 there. So how do you get additional workloads into your cloud? Well, we have an inference endpoint implementation in our dashboard. You're not stuck to this. Our tool can actually use any inferencing deployment platform, and there's a bunch of them out there, and they're getting more and more rich with features over time. So as those features are introduced in inferencing endpoints, that still seamlessly knits into the EGS product. And I'm going to show you how easy it is. Again, as a quick reminder, we have one GPU that's available, and it's sitting somewhere. We don't know, we don't care. Well, we do know because it's right here. Let's say we didn't know, and I want to deploy, say, an additional bursting inference, meaning, okay, I'm running a current model. This model might be running out of steam. I may just need a different location and different geolocality for a model. I'm going to let the system figure that out. And if anybody's ever tried to deploy Hugging Face, and again, spent many hours of your life trying to make sure that your NVIDIA colon 1 GPU and your NVIDIA SMI commands actually produced output. This is how easy it is to do. We literally click the model that we want. We tell it, this is our magic button. This says, this is hard to read, but burst to available clusters. That means I'm going to go through this list automatically. I'm going to find a GPU that's available, and I'm going to deploy this model to any available GPU that I happen to find that fits all the policy bells and whistles. And as I click that to deploy, it's going to start spinning up this workload. So my job as a DevOps is done. That model's now being deployed into a namespace that happens to be on a cluster that's in, I think, Chicago. So that, many hundreds of miles away, we have a Llama model spinning up, and that's how our burst is working. And we'll start to see that come online and be put into play. From here, once we kind of have that utilization piece, you can see these are now starting to build up, and I'm starting to get more usage into my cluster, which is awesome. I can also now drill into my costs. And I hope my CEO closes his ears, because I've spent a lot of money on this demo since the beginning of the month. But this will tell me that I've spent $1,100 on GPUs since the 1st of November. Of that $1,100, I allocated just over $1,000. So I wasted $116 in terms of allocation, i.e., I didn't have something allocated, so it was just throwing money out the window. $116. Of this $1,022, I actually utilized about 75% of that spend, meaning that GPU was cranking on numbers and crunching numbers and hopefully getting most of the numbers correct, as GPUs are likely to do from time to time. And so of my $1,000, I wasted $250. And then I can drill down further and I can say, okay, of my teams or my projects, where was that money spent? I allocated to the burst inference $460. I only utilized $320. VLLM, my demo for VLLM, I allocated $400. I utilized $350. Not too bad. My inferencing slice, again, some deltas there, and you just keep going down through your workspaces. Even if a workspace doesn't exist anymore, we still keep track. We were doing edge inferencing, about $7 there, about $2 on a Copilot for coding. And then even deeper down the rabbit hole within those workspaces, you can look down to the individual job, the individual model that's running on the network, and say, how much did that specific model cost me? $265 for Llama 3, $179 for our other Llama 3 bursting. There's a Gemma here that was $45. So this gives you really great visibility. We believe this is unique in the industry to be able to see down to that workload, again, across clusters. This is not a single cluster usage, but these workspaces span multiple clusters. So this might be made up of Akamai. I'll just say multiple regions of Akamai, right? Multiple clusters in Akamai can all be...
You don't need to know.
That's right. Can all be combined into that single cost, that multi-cluster, cross-cluster capability. Very unique and very powerful. The last thing you want to do is look at your actual GPU metrics. These are straight off the line from DCGM, if you're familiar with that. So I can look at wattage, I can look at power, I can look at trends to my usage. I can look at temperatures, I can look at memory utilization, all of the things. So that's EGS in a nutshell. And I think we're going to go back and complete a couple extra slides. By all means, if there's any questions on this one, you want to double click into something you've seen on the screen, understand a little bit more, please come on up after the presentation and we'd love to go through that with you. Last couple slides here just to round us out for the day. our EGS overview. Everyone likes a pseudo stack diagram, so we've provided one. We talk about the use cases that you can use for EGS, batch workloads, multi-cluster inferencing, fine-tuning, multi-cluster load balancing, secure RAG. All of these use cases are relevant, timely in our technology cycle where we are today. Elastic Grid Service has a few different things under the hood in terms of the slice, in terms of the scaling. Agentic is coming into the picture. We talk about the predictive scaling, the multi-tenancy, telemetry / FinOps. We talk about the resource management, workload distribution, workload placement. Really powerful concepts and constructs in our software, again, to be able to distribute and actually place those workloads, and all built on an open ecosystem, supporting many different Kubernetes deployments. We love LKE Enterprise, all great candidates to go host your workloads. And I think we're going to peel away there. Super duper geeky slide for, again, those who want to come up and have any additional questions on that one. So thank you all for your time today, and we'll be around for a little bit. Come say hey to Raj, and I'd love to meet anyone else who would like to talk about EGS. Howland.
Thank you, Dave, so much. Thanks for a great demo. The chips you mentioned, RTX 6000s, they are available right now. We just announced that back in October. That's going to be great. Really, there's AI, amazing things going on there. I just got to tell you, the cost breakdown, that's sweet, right? We know creating those AI images of your friends doing things they're not doing. It's fun, but it costs real money. That's great.
Yeah.
Any questions from the crowd? Nathan, anything you want to chat? Nathan's good. All right, come up to us afterwards. I know you guys are a little nervous. We'll have the one-on-one conversations. We'll do some cool stuff with the demo. And so thanks to Avesha and Dave and Nathan for being here. Appreciate it. Cheers.
Thanks, Colin.